United States, hazardous locations are classified based on the type of hazardous material present and the likelihood of a hazardous atmosphere existing. Class 1 refers to locations where flammable gases or vapors are present. Division 2 indicates that a hazardous atmosphere is possible, but not likely to exist under normal operating conditions. When selecting connection cables for Class 1, Division 2 hazardous locations, several factors must be considered to ensure safety and compliance with relevant standards. Several suppliers offer cables specifically designed and listed for Class 1, Division 2 applications. These include Southwire, Belden, Prysmian Group, Requesters Soprano Cable Corp., and General Cable. Their websites provide detailed information on their product offerings for hazardous locations. When choosing cables, it is essential to consider certain specifications. Firstly, the cable must be listed for use in Class 1, Division 2 hazardous locations by a nationally recognized testing laboratory, such as Underwriters Laboratories or the Canadian Standards Association. Secondly, the outer jacket should be resistant to oil, sunlight, and to the harmful substances present in the hazardous environment. Thirdly, conductors should be made of copper or a suitable alloy. Fourthly, insulation should be rated for the appropriate voltage and temperature range. Fifthly, the cable should have a suitable armor or sheath for protection against physical damage. In addition to these specifications, several additional considerations are important. 1. It is always recommended to consult with a qualified electrician or engineer to ensure that the cables meet all applicable codes and standards, including the National Electrical Code. 2. Install cables according to the manufacturer's instructions and the National Electrical Code. 3. Use proper cable glands or fittings to maintain the integrity of the hazardous location. 4. Regularly inspect and maintain cables to ensure their ongoing suitability for the application. When selecting a cable, confirm it adheres to UL 2225, the standard for cables and cable glands for use in Class 1 and Class 2, Division 1 and 2 hazardous locations. This standard outlines the requirements for cables used in hazardous locations, ensuring they are designed and tested to withstand the harsh conditions and prevent explosions or fires. The cable must also meet the requirements outlined in the National Electrical Code, specifically Article 500 through 505, which covers hazardous locations. NEC 500 contains the general requirements, while NEC 505 details zone classifications. The cable must be suitable for the specific environmental conditions of the hazardous location, including temperature, humidity, and exposure to chemicals. Consider the ambient temperature range and select a cable with a temperature rating that exceeds the maximum expected temperature. Chemical resistance is crucial to prevent degradation of the cable jacket and insulation. Ensure the cable's materials are compatible with the chemicals present in the environment. Select a cable with the appropriate voltage rating for the application. The voltage rating should be equal to or greater than the maximum voltage of the electrical system. Cables used in hazardous locations are often exposed to physical stress, such as abrasion, impact, and vibration. Choose a cable with adequate mechanical protection, such as a metallic braid or armor. The cable should have a flame-retardant jacket that meets the requirements of UL 1685 or IEC 60332-3. This will help prevent the spread of fire in the event of an electrical fault. The cable's insulation must have a high dielectric strength to prevent electrical breakdown. The dielectric strength is the maximum voltage that the insulation can withstand before failing. Select a cable with an appropriate ampacity rating for the application. The ampacity rating is the maximum current that the cable can safely carry without overheating. Cable glands and fittings are used to connect cables to equipment and enclosures in hazardous locations. These glands and fittings must be explosion-proof and meet the requirements of UL 2225 or IEC 60079-1. The selection of cable glands and fittings depends on the cable type, size, and the type of enclosure to which it will be connected. Cable glands and fittings must provide a tight seal to prevent the ingress of flammable gases or vapors. When installing cables in hazardous locations, it is essential to follow the manufacturer's instructions and the National Electrical Code. Cables must be supported and secured properly to prevent damage and strain. Use appropriate cable trays, clamps, or other supports to maintain cable spacing and prevent abrasion. Cables must be grounded properly to prevent electrical shock and static discharge. Grounding conductors should be sized according to the National Electrical Code. All electrical equipment in hazardous locations must be properly grounded and bonded to ensure a safe and reliable electrical system. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault currents. Cables in hazardous locations should be inspected regularly for signs of damage such as cuts, abrasions, and chemical degradation. Damaged cables should be repaired or replaced immediately to prevent electrical hazards. Keep detailed records of all cable installations, inspections, and maintenance activities. This information will be helpful for troubleshooting and future maintenance planning. Cable suppliers can provide technical support and assistance with cable selection and installation. Consult with a qualified electrician or engineer for guidance on hazardous location wiring practices. Remember, safety is the top priority when working in hazardous locations. Always follow proper procedures and use appropriate equipment to minimize the risk of accidents. Selecting the correct cable for Class 1, Division 2 locations is an important task. Firstly, you need to understand the specific requirements of the hazardous location. This includes identifying the type of hazardous material present, the degree of likelihood that a hazardous atmosphere will exist, and the environmental conditions. Secondly, compare the offerings of various cable suppliers. Several reputable manufacturers specialize in cables for hazardous locations. Thirdly, always consult with a qualified electrician or engineer. These professionals can help you navigate the complexities of hazardous location wiring and ensure that your installation meets all applicable codes and standards. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations in the United States. It provides detailed requirements for wiring in hazardous locations, including cable selection, installation, and maintenance. It is essential to consult the NEC and any other applicable local codes and standards to ensure compliance. The selection of appropriate cable glands and fittings is crucial for maintaining the integrity of the hazardous location. These components must be explosion-proof and designed to prevent the ingress of flammable gases or vapors. Select cable glands and fittings that are compatible with the cable type, size, and the enclosure to which it will be connected. Proper grounding and bonding are essential for preventing electrical shock and static discharge in hazardous locations. Grounding provides a path for fault currents to flow back to the source, while bonding connects all metal parts of the electrical system together to create a low impedance path. Follow the NEC requirements for grounding and bonding to ensure a safe electrical system. Regular inspections and maintenance are critical for ensuring the ongoing suitability of cables in hazardous locations. Inspect cables for signs of damage, such as cuts, abrasions, and chemical degradation. Damaged cables should be repaired or replaced immediately. Keep detailed records of all cable installations, inspections, and maintenance activities. The selection of cables for Class 1, Division 2 hazardous locations is a critical task that requires careful consideration of various factors. By understanding the requirements of the hazardous location, selecting appropriate cables and accessories, and following proper installation and maintenance practices, you can ensure a safe and reliable electrical system. The choice of cable in hazardous locations is paramount to preventing explosions. Firstly, choose the correct cable type and construction. Cables must be specifically listed and labeled for use in Class 1, Division 2 locations. These cables are designed to contain explosions within the cable itself and prevent them from propagating to the surrounding environment. Secondly, verify the cable's temperature rating. Ensure the cable's temperature rating is suitable for the ambient temperature and the potential heat generated by the electrical equipment. Overheating cables can degrade insulation and increase the risk of ignition. Thirdly, look into chemical compatibility. Consider the chemical environment in the hazardous location and select cables with jackets and insulation that are resistant to the chemicals present. Chemical exposure can degrade cable materials and compromise their explosion-proof properties. Fourthly, ensure the proper installation and support. Install cables according to the manufacturer's instructions and the National Electrical Code. Provide adequate support to prevent stress and strain on the cables, which can damage the conductors and insulation. Fifthly, maintain and inspect regularly. Conduct regular inspections of cables for signs of damage such as cuts, abrasions, and chemical degradation. Replace damaged cables immediately to maintain the integrity of the explosion-proof system. Cable glands and fittings used in hazardous locations must be explosion-proof and listed for use in Class 1, Division 2 locations. These fittings provide a secure connection between the cable and the equipment enclosure, preventing the escape of flammable gases or vapors. Firstly, ensure proper sealing. Select cable glands and fittings that provide a tight seal around the cable to prevent the ingress of flammable gases or vapors. The sealing material must be compatible with the cable jacket and the environmental conditions. Secondly, verify the grounding and bonding. Cable glands and fittings must provide a reliable ground connection between the cable shield and the equipment enclosure. Proper grounding and bonding are essential for preventing static discharge and electrical faults. Thirdly, follow the installation instructions carefully. Install cable glands and fittings according to the manufacturer's instructions, using the correct tools and techniques. Improper installation can compromise the explosion-proof properties of the fitting. Fourthly, check the compatibility with the cable. Select cable glands and fittings that are compatible with the cable type, size, and construction. Mismatched components can compromise the seal and the explosion-proof properties. Fifthly, inspect and maintain regularly. Conduct regular inspections of cable glands and fittings for signs of damage, corrosion, or loosening. Tighten or replace fittings as needed to maintain a tight seal and a reliable connection. The National Electrical Code provides specific requirements for cable selection and installation in Class 1, Division 2 hazardous locations. It is essential to consult the NEC and any other applicable local codes and standards to ensure compliance. Firstly, refer to Article 500. The NEC Article 500 covers the general requirements for hazardous locations. It defines the different classes, divisions, and zones of hazardous locations and provides guidance on selecting appropriate equipment and wiring methods. Secondly, look at Article 501. NEC Article 501 provides specific requirements for Class 1 hazardous locations. It covers topics such as wiring methods, sealing requirements, and equipment selection. Thirdly, consider Article 502 and 503. NEC Articles 502 and 503 provide requirements for Class 2 and Class 3 hazardous locations, respectively. While these articles may not be directly applicable to Class 1, Division 2 locations, they can provide valuable insights into hazardous location wiring practices. Fourthly, ground properly, which is covered in Article 250. NEC Article 250 covers the requirements for grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock and static discharge in hazardous locations. Fifthly, overcurrent protection is covered in Article 240. NEC Article 240 covers the requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, must be selected and installed to protect cables and equipment from overloads and short circuits. The selection of connection cables for Class 1, Division 2 hazardous locations requires careful consideration of various factors, including the type of hazardous material present, the environmental conditions, and the applicable codes and standards. By following the guidelines outlined in this narration and consulting with qualified professionals, you can ensure a safe and reliable electrical system. When specifying cable for a Class 1, Division 2 location, begin by understanding the specific hazardous substance involved. Class 1 locations involve flammable gases or vapors, but the specific gas or vapor dictates the cable's material compatibility. Methane, propane, gasoline, and various other substances each react differently with cable jacketing and insulation. The cable must withstand prolonged exposure to the specific substance without degrading, cracking, or losing its electrical insulating properties. Secondly, consult chemical compatibility charts provided by cable manufacturers. These charts detail the resistance of various cable jackets and insulation materials to specific chemicals. For example, a cable jacket made of polyvinyl chloride might be suitable for some chemicals but degrade rapidly in the presence of others. Select a cable whose materials are rated for long-term exposure to the specific hazardous substance present. Thirdly, consider the ambient temperature range of the location. Hazardous locations often experience extreme temperatures, both high and low. The cable must be rated for the full temperature range expected in the location. Exceeding the cable's temperature rating can cause the insulation to melt, crack, or become brittle, leading to electrical shorts and potential ignition of flammable substances. Fourthly, specify a cable with a robust outer jacket to withstand physical abuse. Cables in industrial environments are often subjected to abrasion, impact, and flexing. A durable outer jacket protects the underlying insulation and conductors from damage. Look for cables with jackets made of materials like polyurethane or cross-linked polyethylene, which offer excellent abrasion and impact resistance. Fifthly, ensure the cable meets the requirements of UL 2225 or other relevant standards. UL 2225 is the standard for cables and cable glands for use in Class 1 and Class 2, Division 1 and 2 hazardous locations. Cables that meet this standard have been rigorously tested to ensure they can contain explosions and prevent the propagation of flames. Specifying a UL 2225 listed cable provides an added layer of safety and helps ensure compliance with regulatory requirements. Furthermore, proper installation is crucial for maintaining the integrity of the cable system in a hazardous location. Firstly, use only approved cable glands and fittings. Cable glands and fittings used in hazardous locations must be specifically designed and listed for use in those locations. These fittings provide a secure connection between the cable and the equipment enclosure, preventing the ingress of flammable substances and containing any potential explosions. Secondly, follow the manufacturer's instructions for installation. Always follow the cable manufacturer's instructions for installation, including proper torque settings for cable glands and fittings. Over-tightening can damage the cable or fitting, while under-tightening can compromise the seal. Thirdly, provide adequate support for the cable. Cables in hazardous locations should be supported at regular intervals to prevent strain on the cable and its connections. Use approved cable supports and hangers to maintain proper spacing and prevent abrasion. Fourthly, avoid sharp bends in the cable. Sharp bends can damage the cable's insulation and conductors, increasing the risk of electrical shorts and potential ignition of flammable substances. Follow the cable manufacturer's recommendations for minimum bend radius. Fifthly, inspect the cable regularly for damage. Regularly inspect cables in hazardous locations for signs of damage such as cuts, abrasions, or chemical attack. Replace damaged cables immediately to prevent potential hazards. The NEC provides detailed guidance on wiring methods for hazardous locations. It is essential to consult the NEC and any other applicable local codes and standards to ensure compliance. Firstly, understand the requirements for sealing. Sealing fittings are required to prevent the passage of flammable gases or vapors from one area to another. The NEC specifies the types and locations of sealing fittings required for different hazardous locations. Secondly, follow the requirements for grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock and static discharge in hazardous locations. The NEC specifies the size and type of grounding conductors required for different equipment and wiring systems. Thirdly, adhere to the requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, must be selected and installed to protect cables and equipment from overloads and short circuits. The NEC specifies the size and type of overcurrent protection devices required for different circuits. Fourthly, use approved wiring methods. The NEC specifies the approved wiring methods for hazardous locations, including the types of conduit, cable, and fittings that can be used. Only use wiring methods that are specifically listed and labeled for use in hazardous locations. Fifthly, maintain proper spacing between cables. The NEC specifies the minimum spacing requirements between cables in hazardous locations to prevent overheating and the spread of fire. Maintaining proper spacing helps ensure that cables can dissipate heat effectively and that a fire in one cable will not easily spread to adjacent cables. The selection and installation of connection cables for Class 1 Division 2 hazardous locations require a thorough understanding of the applicable codes, standards, and best practices. By following the guidelines outlined in this narration and consulting with qualified professionals, you can help ensure a safe and reliable electrical system. When selecting cable, consider the following factors in greater detail. Firstly, flame retardancy is crucial. Cables must be flame retardant to prevent the spread of fire. Look for cables that meet UL 1685 or IC 60332-3 standards. These standards specify the testing methods and performance requirements for flame retardant cables. Secondly, moisture resistance is important. Cables must be resistant to moisture to prevent electrical shorts and corrosion. Look for cables with moisture-resistant jackets and insulation. The NEC provides guidance on selecting cables for wet locations. Thirdly, UV resistance is needed for outdoor applications. Cables exposed to sunlight must be UV resistant to prevent degradation of the jacket and insulation. Look for cables with UV-resistant jackets made of materials like polyethylene or polyurethane. Fourthly, flexibility will reduce stress. Select flexible cables for applications where frequent flexing or bending is required. Flexible cables are designed to withstand repeated bending without damage. Look for cables with stranded conductors and flexible jackets. Fifthly, shielding minimizes interference. Shielded cables are used to minimize electromagnetic interference, or EMI, and radio frequency interference, or RFI. Shielding can be provided by a metallic braid or foil around the conductors. Consider the potential sources of EMI and RFI in the hazardous location and select shielded cables accordingly. Selecting the appropriate cable size is critical for ensuring safe and reliable operation. Firstly, determine the ampacity requirements. The ampacity of a cable is the maximum current it can safely carry without overheating. The ampacity must be equal to or greater than the calculated load current plus any applicable dirting factors. The NEC provides tables for determining the ampacity of different cable sizes and types. Secondly, consider the voltage drop. Voltage drop is the reduction in voltage that occurs along the length of a cable due to its resistance. Excessive voltage drop can cause equipment to malfunction. The NEC provides guidance on calculating voltage drop and selecting cable sizes to minimize voltage drop. Thirdly, factor in the ambient temperature. The ampacity of a cable decreases as the ambient temperature increases. The NEC provides dirting factors for different ambient temperatures. Adjust the cable size accordingly to account for the ambient temperature. Fourthly, account for conduit fill. The NEC limits the number of cables that can be installed in a conduit to prevent overheating. The conduit fill must be calculated to ensure that the cables can dissipate heat effectively. Fifthly, consider the length of the cable run. The longer the cable run, the greater the voltage drop. For long cable runs, it may be necessary to increase the cable size to minimize voltage drop. Cable glands and fittings are used to connect cables to equipment and enclosures in hazardous locations. These components must be explosion-proof and meet the requirements of UL 2225 or IEC 60079-1. Firstly, select the appropriate type of fitting. Different types of cable glands and fittings are available for different cable types and applications. Select the type of fitting that is best suited for the specific cable and equipment. Secondly, ensure the correct size. Cable glands and fittings must be sized correctly to match the diameter of the cable. Using an incorrectly sized fitting can compromise the seal and the explosion-proof properties. Thirdly, verify the material compatibility. The materials used in the cable gland or fitting must be compatible with the cable jacket and the environmental conditions. Incompatible materials can degrade over time and compromise the seal. Fourthly, consider the ingress protection rating. The ingress protection, or APE, rating indicates the degree of protection provided by the cable gland or fitting against the ingress of solid objects and liquids. Select a fitting with an IP rating that is appropriate for the environmental conditions. Fifthly, follow the installation instructions. Install cable glands and fittings according to the manufacturer's instructions, using the correct tools and techniques. Improper installation can compromise the explosion-proof properties of the fitting. Grounding and bonding are essential for preventing electrical shock and static discharge in hazardous locations. Firstly, establish a grounding electrode system. A grounding electrode system provides a low impedance path for fault currents to flow back to the source. The NEC specifies the types of grounding electrodes that can be used and the requirements for installing them. Secondly, bond all metal parts together. All metal parts of the electrical system, including equipment enclosures, conduit, and cable trays, must be bonded together to create a low impedance path for fault currents. The NEC specifies the methods and materials that can be used for bonding. Thirdly, use approved grounding conductors. Grounding conductors must be sized according to the NEC and must be made of copper or other approved materials. Green insulated conductors are typically used for grounding. Fourthly, connect equipment grounding conductors to equipment. Equipment grounding conductors must be connected to the equipment enclosure and to the grounding electrode system. This provides a path for fault currents to flow back to the source in the event of an electrical fault. Fifthly, test the grounding system regularly. The grounding system should be tested regularly to ensure that it is functioning properly. The NEC specifies the testing methods and acceptance criteria for grounding systems. Regular inspections and maintenance are essential for ensuring the ongoing safety and reliability of electrical systems in hazardous locations. Firstly, conduct visual inspections. Conduct regular visual inspections of cables, cable glands, fittings, and equipment for signs of damage, corrosion, or loosening. Replace or repair damaged components immediately. Secondly, test the grounding system. Test the grounding system annually to ensure that it is functioning properly. Measure the resistance of the grounding electrode system and verify that it meets the requirements of the NEC. Thirdly, perform insulation resistance testing. Perform insulation resistance testing on cables and equipment to detect any degradation of the insulation. Low insulation resistance can indicate potential electrical faults. Fourthly, calibrate and test protective devices. Calibrate and test protective devices such as circuit breakers and fuses regularly to ensure that they are functioning properly. Overcurrent protection is essential for preventing electrical overloads and short circuits. Fifthly, keep records of all inspections and maintenance activities. Maintain detailed records of all inspections, tests, and maintenance activities. These records will be helpful for tracking the performance of the electrical system and for identifying potential problems.